Okay, we're going to look at horizontal asymptotes now. So we're going to look at the same function again of y equals 1 over x minus 3. We said in a previous video that we have a vertical asymptote at x equals 3. We knew that by setting the denominator equal to 0 and solving for x. So we're now focused on horizontal asymptotes. So these are asymptotes that run left to right. And so to really kick this off, understand that we're really trying to answer this question. What is happening to y as x approaches infinity? That arrow to the right means it approaches. In other words, x is becoming a very big number. So what if x were 1,000,000? Or what if x is approaching negative infinity? So what if x is negative 1,000,000? Okay? So what we're really focused on here on our graph is the extreme ends. Okay, so what is happening to y on our extreme ends? Okay, well, go back to your function for a moment. If we were to plug in 1,000,000 right here for x, we would have 1 divided by 1,000,000 minus 3. Well, that minus 3 is not really going to have much of an effect on things. Okay, so you basically just have 1 divided by 1,000,000. Think about 1 pizza divided by 1,000,000 people. Well, if you're lucky, you might get a tiny little crumb, okay? So it's essentially 0. It's not exactly equal to 0, but it's pretty darn close to 0, okay? So, and you can kind of see that on our graph here, that we really have a horizontal line, so that's at HA for our abbreviation, at y equals 0. Once again, it's a boundary line that the curve is going to approach, but it's not going to cross over, okay? So we can see it pretty clearly from our graph, but what if we didn't have a graph to look at? Well, from the equation here, we can see that if we were to plug in something really big, like 1,000,000 or negative 1,000,000, okay, we say that this is bottom heavy. And if it's bottom heavy, in other words, there's more weight in the bottom, then it's always going to be at y equals 0. So let's generalize that. So suppose we're dealing with this generic form of a function where k and b are constants. So they're just numbers, okay? Well, if x is getting super big or super small, so again we're talking about what if x is 1,000,000 or negative 1,000,000, okay? Then the function is going to be bottom heavy, okay? There's more weight in the denominator. And therefore, this is our symbol for therefore, you're always going to have a horizontal asymptote at y equals 0. Okay, there's no work to do. Like with VAs, we had to set the denominator equal to 0 and solve. If it's bottom heavy, it's just going to be y equals 0 every single time. Okay, here we have a few examples where we are looking to state the equations of any asymptotes. So let's first take care of all of our VAs. Remember, this is where we're going to set our denominators equal to 0. Notice with examples 2 and 3, we have some numbers on the end. We said how that is not going to affect our VAs. So usually you can just do this pretty quickly in your head. So with the first one, x equals 2. Second one, and x equals negative 1, we'd have a VA. And the third one, x equals 0. All right, now our HAs. Well, the first one, this is bottom heavy. Again, if you were to plug in 1,000 or 1,000,000 for x, you would have 4 divided by something huge, which is essentially 0. So y equals 0. HAs are always y equals, VAs are always x equals. Okay. Next one here, a little bit more complicated. Yes, this is bottom heavy. Again, if you were to plug in 1,000,000, okay, right here for x, this piece right here, you would have an HA at y equals 0, but then this plus 3 is going to shift it up 3. So that really means our HA is going to go from y equals 0 to y equals 3. So be careful of these shifters. Okay, again, right here, you really would have an HA at y equals 0, but then that minus 4 is going to shift it down. So y equals negative 4 would be the equation for your HA there. Alright, next up. What if we have a function that is not bottom heavy? Okay, in other words, as x gets really big, we're trying to figure out what is happening to y. All right, remember that's the whole idea behind a horizontal asymptote. All right, x is getting either really big or really small. Okay, so we could also say x is approaching negative infinity. So either way, okay, what is happening to y? Well, if I were to plug in something like 1,000,000, okay, into this function where I see an x. Now, the a, the b, the c, and the d, those are all constants. They're just numbers. Okay, x is the only variable here. So if I were to plug in 1,000,000, this plus b and that plus d on the end, they're not going to have much of an effect on things. Really, the only thing that's going to have much of an effect is the a and the c, since they're being multiplied, okay, to x. So if I were to plug in 1,000,000, all right, you would have a times 1,000,000 divided by c times 1,000,000. Well, wouldn't these millions essentially cancel each other out, right? So that would leave you with what we call the ratio of the coefficients. So the numbers in front, in other words. So notice here too that this is not bottom heavy, okay? We actually have equal powers, all right? Really, this x and this x have a power of 1. So if you have equal powers like that, we say that the HA is going to be the ratio of the coefficients. So let's write that down. Okay, so jot that down. We're going to have a horizontal asymptote at what we call the ratio of the coefficients when you have equal powers. Okay, so in this case, the HA would be at y equals a over c. Let's look at some examples. Okay, in these examples, we're just looking to find the horizontal asymptotes. We won't worry about vertical asymptotes. So again, what this is essentially saying is what is happening to y as x gets really, really big. Okay, so it's really important to keep that question in mind. So in our first example here, again, we see that we have equal powers. Please excuse the motorcycle driving by. So you have equal powers, okay? So what that means is it's not bottom heavy, all right? So we're going to have an HA at what we call the ratio of the coefficients. That just means the numbers here in front. So y equals 3 over 4. And again, understand why. If I put 1,000 in here for x and 1,000 in there, subtracting 1, adding 2, it's not going to have much of an effect if we're putting in 1,000. So you have 3 times 1,000 divided by 4 times 1,000. Again, the 1,000s will cancel out, leaving you with just 3 over 4. Okay, so this would be your horizontal boundary line. Okay, your asymptote line. Next one here, once again, we see we have equal powers. Okay, so it's not bottom heavy. So, and by the way, if it were top heavy, then you don't have any asymptotes. Okay. Well, you at least don't have a horizontal asymptote. We'll leave it at that. That's not really something we look at in this course. Either it's bottom heavy or you have equal powers. So here, the ratio of the coefficients, well, there's really ones in front there, even though we don't see it written. Okay? And the last one here, once again, we see that these are the same. And really, with this course, you're only going to see linear functions for your top and your bottom. Okay? So, you know, you're not really going to see 8x cubed and then 4x cubed in the bottom. Okay? So, equal powers, they each have a power of 1. So you really have 8 over 4. We're not going to leave it as 8 over 4. We're going to write it as y equals 2. Okay? So don't forget your y equals for all of your HAs. Please excuse my phone dinging. Okay, goodbye.